Today, I want to talk about all the things that I have learned in my second year of software engineering. I have found that the more insightful things that I learned this year have been much more vague than in the first year, but I will do my best to try and contextualize it enough for you to understand the value of my insights. One more thing. What follows are my personal realizations, reflections, and opinions, so keep that in mind. The first thing that I learned is related to mentorship. Around 11 months into my job, I was given the responsibility of mentoring an intern with a more experienced coworker ready to help. After the intern left, I was helping a very experienced new hire get onboarded on a project that I am leading. Also, around a year and a half in, I got a full-time new grad to mentor. In other words, the past year has had a lot of mentorship workload given to me, and let me tell you, it is a lot of work. Both the intern and the new hire took close to 8 hours of work a week, an entire workday, to mentor for the first few months. There are sync meetings, scheduled help sessions, answering their questions, and most importantly, choosing work for them. It all takes time. Additionally, being a good mentor takes a lot of conscious thought and effort, and mentoring interns in particular is extra stressful due to them being at the company for a fixed period of time. I also learned a lot from my mentees, and it's always useful to have forced periods of reflection when your mentee asks for advice on things that you have experience with. A quick note, a video on how to succeed as an intern is coming, so watch out for that. The next thing that I learned, or I suppose that comprehended is a better choice of word, is that you work in a team. There are some pretty big implications in working in a team. You need to understand what the strengths of each team member are, in what way they can cover your back, and how to cover your teammates' back yourself when you see things go awry. For example, I know that if I need help with writing certain types of tests, I can go to person X. If I have a question about component alpha, I can go to person Y. If I need a fresh perspective on a problem, I can go to person Z. These are all strengths that, if you know how to tap properly, can make everyone more effective and productive at a minimal cost for any individual person. Also, here's a weird realization I had as well. Your manager is just as much a member of the team as other devs, but understanding how to benefit from that takes a lot of time. The implication here is that you also need to have their back if something comes up. Keeping the team happy and productive is the job of each team member. Continuing on the topic of team dynamics, I need to talk about trust. Trust is insanely important for team productivity. This is the important point behind needing to cover your teammates' backs. When you know that your team is ready to help if something goes wrong, you can work with confidence. The more you trust your team, the more you can focus on your work without distractions of unnecessary what-if questions. If the entire team trusts each other, the increase in productivity can account for much more than the improvement in the raw technical ability of each individual. I now completely understand why a rejection due to bad cultural or team fit is a valid reason. I have a lot more realizations regarding trust in teams, but I would rather dedicate more time to it in its own separate video at a later time. For example, calibrating trust is an interesting problem, and blind trust is actually quite problematic. That's an interesting video too. There seems to be a lot more here than I could cover in just a tiny subsection of a bigger video. The next realization that I had is that the job of a software engineer is not to write code, but to deliver value. This is actually a realization that builds on the thing I learned last year, that there are many ways to contribute to the company's success. In essence, no matter how cool and well engineered some code is, if it provides no value to the company, then it should not be built. Plain and simple. Now, figuring out what has value is very difficult, but you should always keep this question of, is this necessary, in the back of your mind as you develop code. Yagni and KISS principles ring truer every day for me. Additionally, if your skill set and past experiences have a way for you to deliver more value to the company, most companies that treat software engineers as software engineers and not programmers will allow you to contribute to the company's success even by unorthodox means. As I said last time, I'm very involved in recruiting from the University of Alberta, and it's being recognized. Let's move on to something a bit more actionable. I have come to realize that one of the most important skills for software engineers is knowing how to learn fast. Quite often, you will not be doing the exact same task day in and day out for years on end. You will contribute to project A and then be moved to project B within a vastly different problem space. This will keep happening throughout your career as a software engineer, and therefore knowing how you can onboard on the task and become efficient quickly is invaluable. This means that you need to evaluate what works for you, what doesn't, how often do you need feedback, and how to get others to transfer information to you in a way that you can actually receive. I am still not totally aware of what works best for me, but I can tell that I am improving. One word of advice: take time to evaluate your own learning rate intentionally. If you focus some of your attention to that, you will be able to tell what maybe works and what definitely does not. Alright, I want to provide some insights I have about career progression. One thing that differentiates people of various levels in software engineering is the amount of context that they possess. A junior will just about know the immediate thing that they are working on, and maybe how to put simple code together to accomplish a task. A mid-level software engineer will have the knowledge of what everyone on the team is doing at a high level, and some deeper knowledge on a limited number of components that the team deals with. Now, a senior software engineer will have deeper knowledge of all the components the team deals with, and know at a high level what other teams around them are doing. This extra context that you get with experience reflects in the design feedback, code reviews, and brainstorming meetings. Another thing that is really interesting to see is the efficiency with which more senior people use their tools. Having used the tools every day for many years means that you can just glance at its output and get all the information that you need. I'm saying that as both someone that has gotten very efficient with code search and seeing coworkers with incredible IDE setups. Next, I want to talk about confidence and imposter syndrome. Imposter syndrome is extremely common in all fields of knowledge work, and software engineering is no exception. This seems to stem from the fact that it's so easy to compare yourself to others, and you rarely see others put in all the same work that you are putting in. Imposter syndrome can manifest in different ways, and for me, it showed up as anxiety. It was pretty bad for the first year and 3 months of my full-time work, and then, as I actually understood how long things usually take, I slowly started building confidence. However, my progress of building confidence got a lot faster when I accepted one thing. That one thing is that I don't know jack shit, so I need to stop acting as if I have a reputation of knowing shit to protect. Once I accepted that I don't know almost anything, it got so much easier to reach out for help on my own. And the thing is, everyone is in various stages of not knowing anything about something, so everyone feels the same way. It's not that the discomfort of being new in something went away, but it got significantly easier to manage those first few weeks or months of being new on a project and slowly building up enough context and confidence to be able to actually contribute to the project. Enough about imposter syndrome. I think now is a good time to discuss cognitive load. This is actually a thing that I only realized about a month ago, but excessive cognitive load is very bad for your productivity. That's because your working memory only has so much space, so having to keep significant amounts of useless information only hurts you. For example, for the longest time I had zero filtering on my email. This means that every morning I would come to work to an inbox filled with 40 or more unread emails, of which only maybe 3 had any relevant information. After going through all the emails, I would struggle to start concentrating, because some of my attention was taken up by mentally filtering through all these emails. This is a problem, as I have become less productive for the rest of the day due to increased cognitive load of not filtering my emails. Therefore, this year I will be spending time trying to reduce unnecessary cognitive load. Moving on from that, I want to next talk about code complexity. In university, you are taught that you should build loosely coupled, highly cohesive systems that attempt to minimize complexity. This is really taught as a truism, and you only get a few insights into why you want these properties when you cover code smells. Well, this past year, I finally learned the true cost of complexity. I made a change fixing a small issue that amounted to basically adding an extra value to an enum. What followed was 2 months of playing whack-a-mole with bug reports from other teams, because there were so many crazy, undocumented assumptions built into transitions from one enum value to another. This first-hand experience of making small changes to a tightly coupled, complex system with low cohesion and dealing with the fallout made me realize really fast how high the cost of having such a system is. You have no way to build confidence in making small changes, and going to work just to deal with the fallout of a small change for weeks on end really sucks. The last thing that I want to share with you today, but not the last thing I learned last year, is just how difficult it is to communicate your ideas across. I have a funny story where I asked if an infrastructure team could extend their system to support a slightly different tooling ecosystem. This tooling ecosystem is very large and temperamental, but I needed support for a tiny subset of it because one of our team's customers relied on it very heavily. I asked for the first time last February and the answer was no. I asked again in June and the answer was still no. But this time they gave a reason of, oh, it's super incompatible, bad idea to support it. In September, the issue came to a head when we started to come up with workarounds to support our customer, and the best option we had was writing some insanely ugly looking wrappers with void pointers all over the place. If you're into systems, you know that when you get to that, you need to run. So I finally cracked and wrote a full-on feature request document telling exactly what we need, why we need it, and the solution we have to do if we don't have this feature. An hour later, I get a message saying, oh, that's all you need the support for? We can enable that in 2 lines of code, should be merged tomorrow. Moral of the story is that you should be as specific as you can and realize that communication is extremely difficult when different people have vastly different contexts. Either way, that's about all I had for now, so let's wrap up the video. In this video, I shared 10 things that I have learned in my second year of working as a software engineer. I am excited to see what the next year brings, and I hope to give you more valuable insights on this topic next year. Either way, feel free to ask questions if you have any. I try to respond to all the comments I get, and I have made a few videos based on viewer requests so far. Anyway, thank you for your time. Bye.